You've seen the headlines: DeepSeek V4's API is dirt cheap, 14 cents per million input tokens. But that sticker price hides a $140 million supercomputer owned by a hedge fund. The real story is a mountain of capital, a pre-banned GPU stockpile, and an architecture that makes a 1.6 trillion parameter model cheaper than your morning coffee. By the end, you'll see exactly where DeepSeek's money goes, and why cheap AI tells only half the truth. DeepSeek, the company behind V4, was founded in July 2023 by Liang Wenfeng. It's wholly owned and funded by Highflyer, a Chinese quantitative hedge fund managing roughly $8 billion. That's not venture capital, that's prop trading money. And they didn't just write code. Highflyer poured 1 billion renminbi, about $140 million, into a custom GPU cluster called Fireflyer 2, packing around 10,000 NVIDIA A100 GPUs. That hardware became the foundation for everything DeepSeek built. This isn't a startup that raised funds on a pitch deck, it's a well-capitalized financial firm that purchased the raw silicon before most rivals even knew the chip shortage would hit. The cluster sits in a private data center, fully owned, with no cloud markup. That alone makes the per GPU hour cost radically different from what you'd pay AWS or Azure. And because Highflyer's trading algorithms already use GPU clusters for quant models, they had the expertise to run a supercomputer efficiently. So from day one, DeepSeek's infrastructure costs were subsidized by a hedge fund's balance sheet, not by venture milestones. Before the US government slammed the door on advanced AI chip exports to China, DeepSeek moved fast. It acquired over 10,000 A100 GPUs, the very same chips in Fireflyer 2, ahead of the restrictions. That locked in a massive compute advantage at pre-sanction prices, insulating the lab from supply chain chaos. The payoff? DeepSeek's V3 model was trained for a claimed $6 million, compared to OpenAI's reported $100 million for GPT-4. DeepSeek also says V3 used just 1/10 the computing power consumed by Meta's comparable Llama 3.1. Whether you take those numbers literally or not, the underlying message is clear: owning your own A100 cluster before the ban changes the economics entirely. The $6 million figure isn't marketing fluff, it's partly an efficiency story made possible by having complete control over the hardware. There's no cloud provider middleman taking a margin, no waiting in provisioning queues. The Fireflyer 2 cluster was purpose-built, with custom networking and cooling optimized for large-scale training. The result, a dramatically lower cost per petaflop. And while OpenAI and Meta spent huge sums partly because they trained on much larger clusters spanning tens of thousands of GPUs for months, DeepSeek's tight integration allowed them to squeeze every drop of performance from a smaller, geographically proximate setup. That's the tangible edge of a hedge fund's hardware play. With the hardware secured, DeepSeek turned to architecture. V4 uses a mixture of experts' design. In a 1.6 trillion parameter V4 Pro model, only a fraction of parameters activate for any given token. That means the per token compute cost stays low, even though the full model is astronomically large. To push efficiency further, V4 adopts multi-head latent attention and a KV cache that reuses key-value pairs from previous tokens, slashing the memory footprint. The result? They can serve massive context windows, up to 1 million tokens, without melting their infrastructure. There's also a smaller sibling, V4 Flash, with just 284 billion parameters. While still its tiny active footprint makes it the go-to for cheap, fast inference. Both models share the same million-token context and a maximum 384K output tokens, so the spec sheet is identical, but the underlying economics differ wildly. Think of it like a team where only a couple of experts speak per question. Multi-head latent attention compresses the attention math, and the KV cache reuses earlier work. That combination makes a 1.6 trillion parameter model feel as cheap to serve as a much smaller one. Now let's look at the API pricing page, the sticker you see. For V4 Flash, uncached input tokens cost 14 cents per million and output tokens cost 28 cents. V4 Pro costs more, 43.5 cents in, 87 cents out. But here's the twist: if your request hits the KV cache, meaning much of the context has been seen recently, the price for V4 Flash input plummets to just $0.0028 per million tokens. That's 50 times cheaper. So repeated, multi-turn conversations or long documents that stay cached become absurdly cheap. This isn't just a discount for you, it's designed to cut DeepSeek's own compute cost. Because when the cache hits, the model skips rerunning the heavy attention layers for those tokens, leveraging the exact KV caching architecture we explored. The economic trick? They pass the savings forward, but only when you use the system in a way that also saves them money. And note, the million token context window makes this even more powerful. You can upload a massive document, keep it cached, and then query it repeatedly for almost nothing. It's a pricing mechanism perfectly aligned with their architecture, and it's incredibly smart. But even the best architecture can't deliver these numbers without help from the hardware. DeepSeek's training and inference run on NVIDIA GPUs, and recent leaps in NVIDIA's software stack have been massive. While they don't publish exact figures, engineers familiar with the pipeline estimate that Blackwell's transformer engine, leveraging FP8 and revamped CUDA kernels, can cut inference costs by multiple times compared to previous generations. That alone puts downward pressure on API pricing. DeepSeek has also diversified. V4 now runs on China's domestic AI chips from Huawei and Cambricon. This multi-platform strategy de-risks geopolitical supply shocks and lets them benchmark pricing. If one chip becomes cheaper, inference shifts there. The result is a flexible backend that keeps marginal token costs low. Combined with the MO architecture and KV caching, these hardware and software optimizations ensure the API isn't a loss leader, it's a carefully engineered low-cost service that can still cover its marginal expenses. And the final strategic piece that ties it all together is what they're doing with their older models. Deprecation isn't just housekeeping, it's a deliberate cost-cutting move that funnels everyone onto the most efficient inference path, directly lowering operational overhead. To see the full strategy, look at the deprecation timeline. DeepSeek has announced that its legacy model names, DeepSeek Chat and DeepSeek Reasoner, will be shut down on July 24, 2026. In their place, everyone moves to DeepSeek V4 Flash. That's a forced migration to the model that exploits KV caching most efficiently, maximizing cost savings for DeepSeek. It also consolidates operations. Fewer model variants mean less maintenance, less server fragmentation, and a clearer product line. When you pair this with DeepSeek's recent moves, a $300 million funding round at a $10 billion valuation and IPO preparations for 2027, a picture emerges. The hedge fund that fronted $140 million for GPUs is now positioning an AI giant that can monetize the cheap API brand it built. This consolidation is a classic platform move: capture users with a cheap API, then shed expensive legacy overhead as you head toward public markets. The deprecation date isn't a footnote, it signals that the era of hidden hedge fund subsidies is transitioning to a commercial phase. So DeepSeek's cheap API isn't a miracle of frugality, it's the product of a hedge fund's $140 million bet on hardware, clever software caching, and strategic pricing designed to pull users into a single efficient model. The hidden subsidy kept costs low while masking the real expense underneath.